We're going to solve polynomial equations. So to start with, let's look at an example of a polynomial equation. X squared minus 5x plus 6 is 0, and I want to solve for x. What I'm looking for is I'm looking for an x value which, when I square it and subtract 5 times it and add 6, we come up with 0. Now, if I just plugged in different values, I could plug in infinitely many, and maybe I'd be lucky and I'd come up with 0. The technique for this, though, is to transform this polynomial by factoring it into a product of two terms, and we set that equal to 0. That's easier to deal with because the product of two terms is 0 if one or the other is 0. We call that the zero product theorem, or the zero product result. I'm going to abbreviate theorem THM. And that's saying if box times triangle is 0, either box is 0 or triangle is 0. The only way you can have 0 from a product if one of those expressions is 0. Now we're going to factor x squared minus 5x plus 6. We have x and x. To multiply to get 6 and add to negative 5, we need negative 2 and negative 3. So now my steps are either x minus 2 is 0 or x minus 3 is 0. Now I'm just looking for what x value makes each of these parentheses 0. I can add 2 to both sides. One value is 2. Adding 3 to both sides here, the other value is 3. So this is the solution of that polynomial equation. Normally I don't do this, but let's do a check just to make sure that you know it's correct. If I let x be 2, I'm going to take 2 and plug it in. I have x squared minus 5x plus 6, and the question is that 0? So I get 2 squared minus 5 times 2 plus 6. And sure enough, 2 squared is 4 minus 10 plus 6. We can see with this 4 and 6 is 10. 10 minus 10 is actually 0. So it did check. And without my going through all the steps, x equals 3 will also check. For these problems, the difficulty will mainly be the difficulty in factoring. So for example, suppose I say solve for x. X squared minus 49 is 0. Right away, because I have 0, everything's okay, because then I can write it as a product of two expressions equals 0. The key here is you must have 0. And if I go back here, that's the important part of that zero product theorem. This is difference of squares, so I have the x and the x. Then the square that gives me 49 comes from 7 and 7. One is plus, the other is minus. Now my next step is the product is 0 if one or the other is 0. So you put both possibilities. So either x plus 7 is 0 or x minus 7 is 0. Subtracting 7 from both sides here, we get x is negative 7. Adding 7 to both sides here, x is positive 7. And it's important that we have all the possibilities. So the solution is all the possibilities that would work. We'll go on and do another one. Suppose, as an example, I say solve for x, and I give you the equation x squared equals 12x minus 36. We're going to use the zero product theorem, but we don't have 0 on one side. So that's going to be the first important step, to get 0 on one side. And I always like the x squared part to be positive. To get 0 on one side, I'm going to subtract 12x and add 36. Now in doing that, I get x squared minus 12x plus 36 equals 0. Once I have the 0 on one side, I have the ability to use what's called the zero product theorem. The next step is the minute we have a polynomial, the key is to write it as a product equal to 0. Factoring, we have x and x. This is a perfect square trinomial. To get 36, we have 6 and 6, but it's negative 12, so it's minus 6 minus 6. So now what we're going to do, we say either x minus 6 is 0 or x minus 6 is 0. But both of these are the same. We're going to add 6 to both sides. We get x is 6, x is 6. We write this as our solution. We write x equals 6. And because it appeared twice, sometimes we call it what's called a double root. That shows that it happened 2 times. We'll go to the next page and do a few more examples. For this one, my example I'm going to give, solve for x. We're going to have 2x cubed plus 8x squared minus 50x minus 200 equals 0. The key for these problems is it's all in the factoring. So first step, I have a greatest common factor of 2. I'll factor that out. It's like dividing it out. I have x cubed plus 8 divided by 2, 4x squared, 50 divided by 2 minus 25x, 200 divided by 2 minus 100. That is 0. We factored out the 2. However, it didn't really help us much because now we have 4 terms and we have to further factor. And when we have 4 terms, that is factor by grouping. So we are going to see that we can factor out an x squared from the first, and x cubed by x squared x, 4x squared by x squared plus 4, and now negative 25x minus 100. It leads with a negative, so it's minus 25. Then we factor out, we get a minus over minus positive x, minus over minus plus 4. Now, this is not factored yet. We still are going to have this 2 in front of all this. This is not yet factored. Now we're going to pull out that x plus 4. So this became 2x plus 4. And then when we pull out the x plus 4, it's like dividing by it. We're left with x squared minus 25. This is where it's important to factor completely. In this case, we have to factor further. We have a difference of squares. So before we can solve, we have to do the further factoring. We're going to do further factoring, difference of squares. Our factors are 2x plus 4. Then it's difference of squares. The way I got x squared was x. Then I have 25 with 5. One is plus, the other is minus. I now have 4 terms being multiplied, but I need to get 0. The number 2 will never be 0, so I can't set it equal to 0, but I can set each of these parentheses equal to 0. So we only set the parentheses equal to 0. So the solution for this, it's x plus 4 is 0. That's going to help us. X plus 5 is 0. X minus 5 is 0. Only the parentheses can be made equal to 0 because they have the variable. Finishing this, we know to get rid of the plus 4, we move it over and it becomes negative 4. To get rid of the plus 5, we move it over and it becomes negative 5. To get rid of the negative 5, we move it over and it becomes positive 5. So we have now 3 solutions to this cubic equation. Because we had 3 as our highest exponent, that told us we had 1, 2, 3 solutions. And that's why when we go back here, we had in this one 2 as our highest exponent. We had the 6 appearing twice. That's why we call it a double root.